Hello everyone, welcome to Practical GCP. Today I'll be talking about a topic on connecting to services runs on another VPC network via Private Service Connect, also called PSC. So I'll start with a problem statement on why cross VPC connectivity is a bit of a tricky problem. And what is Private Service Connect, also called PSC? And how do you use PSC to design a solution to connect to services that runs on another VPC network? Of course, I'll show you a demo on what I've tried and what I've achieved with end-to-end solutions. You can see how this actually works. And also, this is a quite interesting thing for me. So I would like to share a future design in my mind of what the microservices networking could look like by utilizing the PSC feature that Google provided. And finally, I'll do a summary on the pros and cons. Okay, first of all, let's have a look at the problem with cross VPC connectivity, right? So no organizations can participate or anticipate exactly how their VPC network is going to be designed. So very often what you end up with is some teams started early, some teams started late, and they all run different services in different teams. So in GCP, it's very typical for this multi-team design that each team own an area or a folder or a bunch of projects in their own area. In this case, Team A owns a GCP project, Team B owns another GCP project, right? They both build services. And then this scenario is Team B, right, has two VPC networks, and some of their stuff is on the shared VPC, which is kind of at organization level, the IPs, side ranges have been reserved and agreed across teams. But they also have other things that are running on the private VPC, right? So let's say in this case, they have deployed a bunch of services on a Kubernetes cluster and many other things on Cloud Run, all exposed by a private load balancer, right? So let's say they've been doing that themselves with other teams on the shared VPC. But suddenly you have Team A, right? Team A may have some shared VPC stuff that they're doing that they can route their traffic into the shared VPC on Team B. However, they also have other services that are running on a private VPC, right? There's no easy way to route the traffic to allow the private VPC, whatever service runs on that, to be routable to the shared VPC, right? Because it's like two private VPCs. If you're trying to route the private one to private one, that's also very difficult because they don't have an agreement or any kind of easy way to connect them. Because the IP range, the side range have never been agreed. So there's a problem, right? So you might be thinking, okay, how about if we just pair the VPCs? Well, here's the problem comes. Imagine this following problem, right? Because on the shared VPC, the IP ranges, the side ranges have already been agreed across the teams at org level. But if you have a private VPC, you can use whatever you like, right? Because that's not visible to the shared VPC side. So if you want to do a peering, then you have the same side range. It's not possible because you've got conflicted IP addresses, right? So that's not going to work. And what about if you say, okay, now let's migrate the private VPC, all of this stuff, into the shared VPC and give it a different side range? That's a problem too, because it's quite a lot of work, about a hell of a lot of work, because you might have egress rules using CloudNet, and then with services that you talk to the external parties, third parties, you might have other service runs on Kubernetes, right? These are resources, infrastructure you've created on GCP. You can't just move it from A to B. All of the IP is going to change, right? All of the connectivity is going to cause a problem as well. So this is a huge amount of work. So that's not easy to do either, right? Okay, let's first talk about what is a Private Service Connect, right? And then we'll talk about how this can actually solve our problem. So Private Service Connect is a capability of Google Cloud Networking that allows consumers to access managed services privately from inside their own VPC network, right? Similarly, it allows managed service producers to host these services, so their own services in their own separate VPC, right? So if you think about the situation we have Team A and Team B, they all can do their own things, right, in their own area. So what does that mean exactly? So it's kind of a way to offer a private connectivity, right, between the two parties. Okay, so let's now look at a diagram from Google So this clearly represents how the relationship of consumer VPCs and producer VPCs and managed services from Google all interact with each other via Private Service Connect, right? So in today's session, we'll be focusing on the endpoint, right, which is the first way of exposing services and connecting the two sides, the consumer and producer side. But I'll go through the three different ways that you can talk to from the consumer VPC to producer VPC or vice versa using Private Service Connect. So the way this works is the Private Service Connect is a Google managed service, right? So basically abstracting all of this complexity of network layer away from you. So you can actually focus on development instead of trying to set up all of this complex network yourself. The first way, using endpoint, is the way it works is you set something up, right? You publish your service. Let's say the one we are referring to most likely goes into this box, which you have some stuff in your organization you need to expose to other teams via a load balancer typically. You have your internal load balancer, you say, okay, I want to publish my service, and then on the other side, the consumer will say, okay, I'll put an endpoint in there, then I'll connect to that published service, then you can talk to each other, right? The other thing is the backend service. The backend service, you can see the load balancer happens on the left-hand side. You create a load balancer, you can say this load balancer has a backend service, which is a producer. That something runs on a producer VPC that has been published. So then you can actually talk to the load balancer from the left-hand side, actually, in fact, runs on a producer VPC, right? And the third one is something in preview called the interface. The interface is very similar to endpoint, with a distinct difference is that if you connect to, if you create interface for a producer VPC service, then the producer VPC service can actually go back and access your interface service. So producer can access consumer service. So endpoint is one way from consumer to producer. So that's the kind of three different things or ways the Private Service Connect can help you in your to solve your networking problems. Now, let's have a look at how this is going to solve our problem, which is specifically with the PSC endpoint. So same diagram. Left-hand side, you have the teammates GCP project. So in other words, this is all consumer project, right? On the right-hand side, you have the Team B GCP project, which is the producer project, because in subnet 1, they're producing a service exposed via the load balancer. In order to understand how this works, the way I'll describe this is from the right to the left, because that's starting from the service that the producer team is trying to expose, what gets created, and then what gets connected, right? So if you look at the Team B, you've got this subnet, right? This subnet, at the moment, there's a conflict between the two because one is on a shared network, one is on a private network. They don't connect to each other. They have the same silo range, and you can't just put them together, it won't work. But what happens is this one, let's say the load balancer has an IP of 10.0.0.2, which is on the subnet 1. This one, what you do is, as I mentioned in the previous slide, is what you first need to create a PSC, a service, public service, right? You need to publish your service that you own, right, in subnet 1. How do you do that? Right, first of all, you need to create a PSC specific subnet. So in this case, you've got 10.100.0.0/24. So this subnet, the silo range, is dedicated for the PSC, right? It's not used by anything else. And within this subnet, you can publish your service, right? When you publish your service, you need to choose a internal load balancer endpoint. So in this case, when you publish your service, you can say, I'm going to publish the service, and then I'll choose 10.0.0.2 as my load balancer. So that will gain the connectivity to your backend, such as whether that's GKE or Cloud Run, it doesn't matter, right? And then because your service is now published on the consumer project or teammates project, you can create something called a PSC endpoint, right? This endpoint will allow you to connect to your public service. Each public service will generate something called a service detachment. That service detachment has a unique, URI, right? So that one is something you can include when you're creating the endpoint. In addition, when you create the endpoint, you will have to choose a IP address on a specific subnet. So in this case, you can see I'm not touching my service, which currently runs on the virtual machine, has an IP of 10.0.0.1, right? It's in the same subnet and has a conflicted side range. However, by creating a PSC endpoint, I can choose a specific IP. You can reserve it as a static IP. There's no problem with that. And then this one will be your entry point to all the way to your backend services on Team B. So now the connectivity between your virtual machine or any other services runs on subnet 1 would have private connectivity in your own VPC network to the PSC endpoint. So hope this explanation makes sense. I'll show you a demo of what I've actually done to explain exactly again what I just described on the diagram. So hopefully it'll make a lot more sense. So this one is I'm using Cloud Run, right? So this is the Cloud Run service I've deployed. It's just basically a hello world. It's got nothing too interesting. It's just basically a landing HTML page that currently I've restricted this at a network level only to internal, right? So I can't access this. It's hidden behind the load balancer, right? So because I don't have VPCSC, I think a lot of you probably don't have that either. So to keep in mind, if you're thinking about accessing a Cloud Run service from another network, yes, it will work within the same GCP project, but once you're outside of that GCP project, you cannot connect, right? So this is designed to get around all of these problems on the typical network routing, whether you run it on Cloud Run or if you run on Kubernetes. So this is the service, right? The next, let's look at the load balancer. This is the internal load balancer on the IP range, which is 10.0.0/24, right? This one, I've created a HTTPS endpoint with this IP, right? And then I've mapped it to the NEG backend, which is, in this case, is the serverless backend of the Cloud Run service I've deployed, right? So just keep in mind, these things are all in the same region, right? If they're not in the same region, there's additional, you can do it, but there's additional setup. I'm not going to go through it in this session. But for now, assume everything in the same region, right? This is the load balancer, the internal load balancer. The next thing is this public, is where you need to publish the service, right? So this is the most interesting part, because when you publish the service, you're basically creating this service attachment endpoint, right? This is the one you can use on the, you create a service attachment and then you can use later on the endpoint. So what I'll do is actually quickly edit this service so you can see what I've actually put in there. So if you look at from the top, you've got the load balancer, right? You need to choose the internal load balancer. You give it a name, and then you choose a network, you choose a region, and then you choose a subnet. So this is the subnet we have created specifically for PSC, right? So in this case, it's the regional internal application load balancer we're using. There are a few other options you can use as well, but we're using the internal application load balancer, which is typically the most used thing for microservice connecting between different teams, right? And then you have the connection preference. So the connection preference, of course, you don't want to accept any kind of connections. So you can say connecting for selected networks or selected project. So I've done for networks, so it can be more explicit. You can say, I want it to be this project, right, on the sandbox project. And then for the network, this specific network, right, this is the VPC network on this project. I would allow up to 10 connections to be connected to my service, right? So this is pretty much it. So now I have the service attachment. The next step is, now you see I'm creating a connected endpoint, right? This endpoint, if you look at it, so when I'm creating an endpoint, I have specified the service attachment here, right? And then on the other side, I've specified my own network on the consumer side, right? So that earlier, all of that was done on the producer side. This is the consumer VPC. And now I choose a region and I choose an IP. This is the IP that is on the same network, right? On the same network of the producer subnet. So one more thing what I'll do is that if you look at the VPCF setup in here, right? So you've got the producer network, you've got a consumer network. If you look at the producer network, I've got 3 subnets. This one is used for Cloud Run in case I need to connect to do the serverless connector to use privately route traffic to other services on Google Cloud. This is the PSC created specifically for these kind of a Cloud Run backend, but this is specifically for the PSC network that I'm creating for the service attachment. And finally, there is a load balancer endpoint as well. So this is the load balancer reserved on a different side range, and that is specifically for the load balancer itself, right? So there's 3 subnets in here. And then on the consumer side, you can see there's only one subnet, and it's on the 10.0.0.0/24 range. So you can see I've specifically created a IP conflicting situation to kind of route the traffic. So now everything is connected, right? So if I go back to this diagram again, so now this is all done. I made a mistake here, but in this case, the endpoint is actually 10.0.0.10, right? So, and if I show you one more thing on the compute engine, in the compute engine, I have a Bastion PSC demo. This is on the consumer network, and it has IP of 10.0.0.2. Okay, now if you look at this thing, I'm actually connected to I'm inside the Bastion PSC demo machine. So what I'm going to do is, the first thing I'll do is do a netcat. So you can see port 443 is open on the 0.10 IP. So this is our endpoint, right? This is our endpoint. And then if I make a call request, right, this is just basically the HTML, right? This is the landing page of the hello world. You can see I'm using -k to bypass the because it's a self-signed as a self-certificate I've generated. But here you can see I'm actually using the IP address on HTTPS to route this to the Cloud Run traffic. So you see, this is super powerful, right? This is basically, I've literally made up another IP on the same subnet to be able to connect a service owned by another team in the random VPC anywhere in the organization, running Cloud Run. All privately accessed. There's no public it's not going out to anywhere. All this by using PSC, right? Okay, now I want to elaborate this a little bit more on what in my mind of what this thing can do on the future design of microservices networking via PSC. So the example I've given you earlier on, that was obviously just between 2 teams. How about now we have 3 teams? How about we have 4 teams? How about we have 5 teams? How about if some teams are not on shared VPC? Some teams are on shared VPC. So if you think about this kind of scenario, I have another team, have exactly the same problem, same with conflicted IP addresses in there, and then but they can actually create a PSC published service, right? And then same as the team B, but the most interesting part is because team C wants to expose their services to team A, and team A again could be on a private VPC, but all you have to do with this is you create another PSC endpoint to attach to the service that provided by team C with another IP, which in this case is 0.3 and alongside 0.2, right? Obviously, these things you can all do with private domains, but I haven't actually looked into that yet. But now all of the issues, right, that you want to solve from the team that the consumer service, you still have the same subnet. You've not changed anything. You've not migrated anything. You didn't need to any peering, right? And then, but you can connect to any other services hosted by different teams just by having these private IPs in your own subnet. That, in my opinion, is a super powerful thing because it really allows the teams to work together much more seamlessly without needing to align everything on an IP space, right? Because this will allow all sorts of connectivity, but because it's all tracked in the private service connect, you can control it very granularly on which project, which VPC network, and you can see everything, right? So this is super powerful, in my opinion, on the kind of the very different way to manage microservice networking within an organization. Okay, let's do a summary. So there's a few pros and cons kind of I want just to run through with you quickly. So PSC overcomes the limitation and security concerns of VPC peering. So one thing I mentioned about some of the limitations of the IP side ranges, conflicting, you need to align all of that before you can peer your network. But the other thing is also security. One of the things I heard about is if you peer the network, right, so you can actually see the network routing on the other side as well, right, which a lot of the companies is not happy to do that. Let's say if you have a third party running some stuff, do you really want to peer with their network? Not really, because you can actually then, they can see each other's stuff. That's not a good thing, right? So the other thing is the PSC makes changing network design extremely easy. So this keeps reminding me about something Uncle Bob Martin says is good architecture defers decision making, right? So you don't have to get everything right at the very beginning, but if you have something that can easily change stuff later on without asking all teams to do their migrations, and that is very, very good design. I think this applies here as well, because if you think about it, if you have a private VPC, some others have a shared VPC, you have a large organization, you can't align everything, right? In very often the cases. But if you can use Private Google Connect to bridge all of the gaps, and then to manage all of this in a simple way that you can just create an IP in someone's subnet, and then they have access to your service, that is extremely powerful. And in the PSC world, I think what this is going to turn into is, because all teams are going to be decentralized, right? They would be decentralized, having a lot more autonomy, because the network isn't a boundary anymore. You don't have to say, okay, I'm going to need a new subnet. I need to align the network's space, right? The side range with the other teams at the org level first. That's probably have a lead time of a few weeks before you can even start. But if you can just use the private VPC, and then later on, however the connectivity requirements comes in, you can just use PSC to resolve it, and then that means you're still connected, right? You're decentralized, but you're still connected with the rest of the teams. Two things I want to just talk about, because this is quite new, right? This is actually the first time I'm looking at this as well. I'm just quite surprised at how quickly I managed to get this to work. It literally only took me 2 hours. From not even knowing what this thing does to having something that works, proven working, all connected. But it's quite new, right? And then the two things, one thing I want to say is, if you have to do cross-region, so everything I've done here is the same region. But if you have to do cross-region, there's a way you can enable global networking access in there. I have not looked into that yet, but it looks like it's not a problem. But I think in most companies, especially for microservice integration in the private routing, it's probably going to be the same region most likely. If it's different regions, then look into the global access. So again, although this is super cool and super powerful, but one thing keeps telling me is you need to sleep on this. Don't change this stuff overnight, and test it out in a smaller area, and then also making sure you create some kind of ops model to see who owns, who can create this kind of stuff. Because if you just let all of the teams to do this between themselves, it could also turn into a mess on creating concerns on security, which team can access to what, how the service is going to be connected. You probably lose traceability as well. So that's why I'm thinking test it in a small area and start using to see how well it solves the problems, and then roll it out for the rest of the organization, right? Okay, that's everything. Super exciting topic, and yeah, that's all the content I have today, and I'll hope to see you next time. Thank you very much. Bye.
Go out.